Hello guys, welcome back to our channel. In the last video we have discussed about versatile nature of carbon, properties of carbon, halogens and functional groups. We have stopped in the middle of the topic of halogens, and actually that's halogens is completed. We have only 4: chloro, bromo, nitro and ido, and hydro also, which we call as hydrocarbons. Now we divide all these hydrocarbons. We divide all these hydrocarbons into 3 types on basis of the bonds. They are alkane, alkene and alkyne. These are very important for writing. The names of carbon compounds. And in alkanes you can find only single bond, double bond and here triple bond. Simply, the carbon compounds which have single bond are known as alkanes, double bond are called alkenes and triple bonds are called alkynes. For this example is C. It contain only 2 C's. Minimum it should contain 1 C because it should be a carbon compound. So we can take C bonds and this is going to be H. So first we should write the count of the C. How many C's? 2. Okay, and the next count of H is H6, right? Yeah. And the first alkane is CH4. Okay, and many scientists came with confusion to determine what is alkane, what is alkene and what is alkyne. So for that they invented a general formula. What is the general formula for alkane? For alkane the general formula is CnH2n. Simply CnH2n plus 2. Simply the number of hydrogen atoms is twice of carbon atoms in an alkane. I repeat, the number of hydrogen atoms is twice the number of carbon atoms. I repeat it again because this is very important. The number of hydrogens in a carbon compound which is an alkane is twice the number of carbon atoms. So CnH2n plus 2. Okay, and in this we can find the second one is alkenes. Alkenes, it has what I said you, alkenes have double bonds. Okay, alkenes have double bonds, and these double bonds are only between carbons only. This double bond will be considered if it is only between carbon. Okay, and the first compound is, can anyone guess it? If it's C2H2, you are correct. When you compare this with an alkane, with an alkane, alkane required only 1 carbon for first compound, but for alkene you need 2 carbons for the formation of first compound, and simply you can write its general formula. I'm sorry, this is not 2, this is 4. Its general formula is CnH2n. Maybe you can understand this very simply, because the number of hydrogen atoms is just exactly twice the number of carbon atoms. With this we can end the topic alkene, and we also completed alkane. Coming to alkyne, it contains triple bonds. Okay, that again the same situation. The triple bonds will be only considered if they are between carbon atoms. Okay, So what's this formula? What's this formula? Yeah, it's C2H2. The first, this is C2H2, and even the first compound is C2H2. Simply you can tell it as, the general formula is CnH2n minus 2. The general formula is CnH2n minus 2. Means the number of hydrogen atoms compared to carbon atoms. The number of hydrogen atoms are 2 less than twice of carbon atoms. 2 less than twice of carbon atoms. Okay? And there are something called cyclohydrocarbons. That means cycloalkane, cycloalkene or cycloalkyne. For cycloalkane, we have separate formulas. For cycloalkane, we have CnH2n and CnH2n minus 2. And for this, we have CnH2n minus 4. Okay? Good. With this, these are the properties of alkanes, alkenes and alkynes. And from here, the important topic of the lesson starts. That is, I have said you in the first video of this, and this is second part. I have said you this is the most important topic in this chapter. Okay. For these things, for nomenclature, you have to learn root words. You have a format for writing nomenclature. For naming carbon compounds. You have to learn root words for this, and that is mandatory. Root words are based on the number of carbon atoms. Number of carbon atoms, and here root word. Okay? If the number of carbon atoms is 1, the root word will be meth. 2, eth. In the same way, 3, prop, 4, but, 5, pent, 6, hex, 7, hept. 7 is hept, 8 is oct, 9 will be non, and 10th will be dec. Okay, and in this, over this side, I will be telling you the format of naming carbon compounds. The format for naming carbon compounds is, first we need to write. We have two ways for writing this. You can write in brief and detail. Detail includes the position of bonds, substituents and halogens and functional groups, and this bonds also. But if you want to write in brief, those does not include any bonds. And for brief, the formula, the thing will be prefix, root word, and then final one is suffix. Prefix is, yesterday I have said you, functional groups, and suffix is in, an or ein, alkene, alkyne or alkane. Okay, and root word is this one, number of C. C means carbon, number of carbon atoms. Okay, I hope you understand, and we'll do this with an example. We'll start by excluding functional group, going forward step by step, I'll include functional groups and then I'll explain in detail. Let's start with some carbon compound. We'll take some carbon compound. Problem PB, C, C, C and C. For this we'll write the brief name. Prefix. Do we have prefix? Do we have any functional group? What is functional group? Functional group is any other element except hydrogen or oxygen which is added to the carbon compound and gives some special properties. Do we have any other element? We don't have hydrogen and oxygen, and we don't have any other element also. So this does not include any functional group. Root word. How many number of bonds are there? How many carbon atoms are there? 1, 2, 3, 4, 5. So you should write pent, because 5 means pent. You should just keep a dash, and suffix in, n or ein. We find single bonds, but can we find any double bond or triple bond? Yeah, we can find a double bond. Double bond means in. Alkenes have double bond, so E-N-E. Okay, and now you remove dash and write pent in. So this name, the name of this carbon compound is pentene. And we'll do another one now. You should tell me this. Okay, try solving this. Name this carbon compound. I'll just give you 2 seconds of time. Yeah, let me start. Just see any functional group is there. No, we don't have any functional group. Do we have any functional group? No. Now count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7. What is the root word for 7? It's hept. And do we have any single bonds? We have many single bonds. Do we have any double bonds? No. But we have triple bond. Triple bond means alkyne. Alkynes have triple bonds. So hept, Y-N-E. And now you should remove the hash. Heptine. Okay. This is how you write names of carbon compounds in brief. Now we will go and write names of carbon compounds in detail. That means which includes the location of bond or location of functional group or location of halogens, and that have a separate structure. Let me introduce that. I'm erasing this. Yeah, let's start. This format will be long. I have to remember location, prefix, then we have no location again, we have root word, and then location again, and then suffix. Can you guess what is the use of these two locations? I'll tell you. If there is a carbon chain like this, I'm sorry, if there is a carbon chain like this, we can name it as pentene, right? We have already named it pentene, but we can get the same pentene as this form, and we may get 3 other forms also. So we need to know in which place that double bond is present. So suffix means the bond. On depending on bond only we are going to write in, ein or in, right? So if it is this is not required, this location is not required for alkanes, because in alkanes everywhere single bond is there. but in alkenes we have double bond only in one place. We need to know that place for doing the exact carbon chain, right? So we need this location for that. And if I give you some kind of this one, you consider only this one now, bromo. I gave you here. We can write this as bromopentane, pentene, right? But bromopentane only does not mean this one. It can also come as like this also. And for this also we need clarity that where this Br is there and for which one it is bonded in the whole chain. For that clarity we are going to give a location for this prefix also. And now we'll solve some problems related to this thing. We'll start with the simple sums and we'll go till the complicated sums. Okay, let me start by giving you a simple sum. And I have to tell you one thing. If we have carbon chain of this kind and there is C over here, we have to consider the only long chain. Long chain means if we can take this chain and this chain. You can take this chain also, right? 1, 2, 3, 4, 5, 6. This chain consists of 6, this chain consists of 4, and this chain consists of 5. Which is greater? This one. So we have to write 6. 6 means hex. N. No need to write because all these alkanes contain only single bonds. Wherever the bond is required, there is only single bonds present in the place present in alkanes, right? We have to consider only this chain. For prefix, many of you may be thinking now that there is no prefix, but you are wrong. This carbon chain also consists of this one, right? We have to mention this one. We have to mention about that C. But this number hex, this chain numbering should be given according to this chain only. Okay. First, you have to count 1, 2, 3, 4. Okay, I'm sorry. 6, 5, 4, 3, 2, and 1. 1, 2, 3, 4, 5, 6. This carbon, the extra carbon, is between which things? The extra carbon is between which numbers? If we take the upper number line, we'll have from 3 to 4. And if you take the down number line 1, 2, 3, and here also we have from 3 to 4. Wait. Is it correct? I'm sorry, I made a small mistake. This is not 3 to 4. This is just 3. This is only linked to number 3. So that is only going to be 3. And in the down number line, it is 4. You have to write separately like this. And you have to consider the smallest value. What is this? 3 is the smallest value. So 3 in which number line it is there? Upper number line. So you have to write 3 methyl. Meth means 1. If any carbon comes down like this or if any carbon is branched with any carbon atom like this, you have to write root word and the name 3 methyl. Is there any double bond? No, you don't have any double bond. So no need to write location for prefix also, and no need to write location for suffix also. You need to know you should not write location for prefix because you don't have prefix. Am I right? Yeah. Now you should write the root word for whole carbon. You should only consider the long chain. I said you never forget, you should only consider the long chain. The long chain consists of 6. So I wrote hex and N. Simply 3-methyl hexane. This is a very easy sum, and slowly I'll complicate these sums. Okay, I hope you understand. And for the next sum, let me erase this. The next sum we are going to solve is 4, 5, 7. It's going to be this. Yeah, good. And I have to tell you one thing more. From this sum, you have to give preference for you may count from this side and this side also, right? If there is BR here, from which side you are going to count? The bond is this side, so the nearest will be, for the bond the nearest will be here, for functional group the nearest will be here. So which one you are going to consider? There is also a rule. First, functional group is given importance, then bonding is given importance, and then substituents are given importance. Okay, you have to never forget this one. As there are no functional groups over here, which is given the importance? Bond, right? Yeah. Now from which side we are going to count? Obviously this side. We have triple bond, so we can conclude that this is an ine. The suffix is ine, right? Now let's count. 1, 2, 3, 4, 5, 6, 7. This is the longest chain, so we should only consider that one, right? So where is the bond? Between 2 and 3. In 2 and 3, which is the smallest? 2. We have to write 2. Okay? And where is this carbon, extra carbon branch present? At 5. So 5 methyl, because only one carbon is there. 5 methyl. Location of prefix, we don't have prefix, so no need to write. Then root word hept. Where is the bond? Where is the triple bond? At number 2, between 2 and 3, but the smallest is 2. We have to write 2. Hept ine. This is the complex and detailed name that we give to this carbon. Okay. But if you write in a just brief form, you will not include 5 and 2. You can just simply write methylheptane. Okay? Simply we are going to write methylheptane. And I have some more complex sum for you. C6. Okay? And here you have 1C. Here you have 1C, and here you have a triple bond. Name this carbon compound, and I will give you just 10 seconds. I am going to give you only 10 seconds. 5, 4, 3, 2, 1. Okay, let me explain this for you. Here extra carbon chains are there, but the longest chain is only this one, right? The longest chain. And we have a triple bond, that is ine, and the triple bond is between 1, 2, 3, 4, 5 and 6. The triple bond is between 1 and 2, and 1 is the smallest. We have to consider only 1, right? Yeah. So this is an ine because triple bond is there. Okay, this is not the line of the bond, this is just a marking that I brought to explain. Now these carbon chains are there. Why? I'm sorry, it can be, because it's a carbon compound, it can be. We have to write a detailed name. How we are going to write? 4. The carbon branches are there at number 4 and 5. 2 are there. 2. And in 2 places we have 2 branches. So we have to write dimethyl. Dimethyl. How many are there? Hexine. You may wonder why I didn't write the location of the bond. Because 1. As it is 1, there is no need to write 1 in this name. I hope you understood. If you have doubt, you can tell in the comment section, and you can write whatever question you have doubt, you can write in the comment section so that I will solve it for you. Okay? and let's solve the last sum in this nomenclature, and I will give you some sums to solve. I'll give you some sums to solve so that you can get practice, and those sums I will explain you in the next video, so that if anyone have doubt can clarify by seeing that video. Okay. One, two, three, four, five, six. Okay. The triple bond will be here. Okay. And this 1C, 1, 2. Just cool down and never get tensed while doing this sums. Okay. First, check for any prefix. We don't have any prefix. That means we don't have any functional groups. Okay. We don't have any halogens also. Right? We don't have any halogens also. Then we have to see the branches. Where are branches? Now we have to just count this bonding. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It is from both the ways, it is between 3 and 4. So the bonding number will be 3 itself. But it is triple bond, so it will be ine. Okay? It will be ine. Then branches are there. What is the location of branch? Let's take it from the upper side only, so that it will be less confusing. 3. I'm sorry, before 3, at the position of 2, here in the second carbon atom, coming from this side, in the second carbon atom we have 2. 2. What is the root word for 2? Eth. Ethyl. Because 2 are there, and that is branched. For branched, what is said you to write? That is yl. Sorry, for 2 I have said you to write it, and for branched carbon we have to write yl. So finally that is 2 ethyl. 2 is because it is the location of this ethyl. Okay. Then we have another carbon branch, that is 3 methyl. 3 methyl. Now we don't have any prefix, so we can go to root word directly. Hex, and the number of bond is 3. Ine, completed. Okay. This is very simple and you should just understand. And let me solve you a last sum that includes, a functional group and a halogen. C, double bond C, single bond C. Okay. Here we have prefix. Right? But we have prefix, but this is an halogen. Halogen comes under substituent. So this will be given last preference. So we have a double bond over here. Before double bond we have a functional group here. Yesterday in the video I have explained you clearly about a functional group, something like this. Can you guess what's the functional group? It's ketone. We should give importance for functional group even before a halogen, right? But in name we'll get halogen only before. So we'll count it from this side. 1, 2, 3, 4, 5 and 6. Right? Yeah. Now where is first, before everything you have to write the location of this halogen. 5. Which halogen? It's bromine. For bromine, the root word, the suffix word is bromo, and then you have to write the number of carbon atoms before, because you don't have any carbon branch for this. It is hex and double bond, so ene and on, because suffix. No need to Ketone will always come in the middle, so no need to write this one. Ketone will never come at the end. It will never come in this position. So if it is with if ketone is with the second carbon atom in the chain, there is no need to mention any number, because it is considered for ketone that it will come for ketone it will be considered as 1, 2, 3 and 4. This one is not considered for ketone. Okay, this is very easy, right? 5 bromo hex double bond, so ene, and double bond is at 1 and 2, so 1 ene and on. But how are you going to write this name? 2 vowels can't come between, so 5 bromo hex, you have to mix E, you have to remove O and write O in place of E. Okay, O-N-E. 5 bromohexenone is the name of this carbon compound. With this I'll stop nomenclature, and you have to draw structures for this. You can also draw structures for this names, means they'll give names, means they can give this such kind of names, and they may ask you to draw the carbon chain. I'll give you one example and then I'll give you 5 sums to solve. The name given is 2 bromo 3 ethyl penta 1,4 diene. For halogens we give the last preference, right? I have said you for halogens we give you the last preference. The first preference is given to this functional groups, and then bonds. The bonds are between 1 and 2 and 4 and 5, because here only 5 carbon atoms are there, and between the one greater than 4, a number greater than 4 and consecutive for 4 is 5, a number greater than 1 and consecutive to 1 is 2. I hope you understand, right? So let's draw 5 carbon atoms first. 5, right? I think you don't have any doubt in this. 2 bromo 3 ethyl pent. Pent means, sorry, it's not penta, it's just pent. Pent means 5, so I drew 5 carbon atoms. 1,4 diene. What do you mean by di? Di means 2. What do you mean by di? Di means 2. Ene refers to double bond. That means between 1 and 2 and 4 and 5 double bonds are present. I have said you a number greater than 1 and consecutive to 1 is 2, a number greater than 4 and consecutive to 4 is 5. Because here the total is 5 carbon atoms. The total is 5 carbon atoms, and the total will be 5 carbon atoms, and the bonds are 1,4 diene. That means it is the lowest of 2 numbers is 1, and the both numbers should be consecutive, because the bonds are present between only 2 consecutive carbon atoms, but not this and this and this and this. They are only present between this and this. I hope you understand. So according to the name, where are the carbon double bonds present? 1,4. As there are 2 double bonds, they gave di. Di means 2 double bonds in 1, 2 and 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. I gave you double bonds. So this condition is satisfied. We have satisfied this condition. Now we have to satisfy these two. Okay. They gave the location of this halogen 2, means it is connected to this second one. you have to draw the bonds for halogens such that the valency of carbon is satisfied. If you see here, double bond, carbon's valency is 4, right? Carbon's valency is 4. Here double bond, here single bond, means 3 electrons are shared. And if you draw Br with single bond, here another electron will be shared. So it's all 4 electrons are shared. As they gave the location of halogen as 2, I bonded Br with the second carbon atom from our counting 1, 2, 3, 4, 5. Okay. And then 3 ethyl means 3. At the third location means with the third carbon atom, ethyl. Ethyl means branched carbon chains. Means we have 3 ethyl. We have 3 ethyl. Ethyl means 2 carbon branches. Means it consists of 2 carbon atoms in 1 carbon chain. That is what ethyl means. And the location is 3. With this we satisfied this condition also. So this will be the correct answer for this whole question. Now I will give you some kind of 5 questions to you for practice, and then I'll solve them in the next video for your practice. If you solve that, that is the end of nomenclature, and we have 4 important reactions: formation of soaps and detergents, and we have properties of ethanol and ethanoic acid, and reaction of ethanol and ethanoic acid, that is esterification, and formation of soap, that is saponification. If we discuss this in the next video, we can come to the end of this chapter, and then I'll start the new chapter, that is human eye and the colorful world. Now let me give you some sums. Okay, first one that I give you is C 5, 6 and 7 Fl double bonded with O, and here you have a double bond. And fluorine suffix is fluoro. As I didn't said, I have informed you. Okay, and you should draw the structure of 3-bromo, 2-chloro, 5-oxohexanoic acid. This is very important model. You have to try this definitely. If you didn't get, I'll definitely explain you in the next video. Okay. Okay, this one, and then next one, 2-dimethyl. It's not 2-dimethyl actually. Yeah, it's 2-dimethyl. I'm sorry, it's 2-dimethyl propane. The last one I am going to give you is draw the structure of 6-ethyl oct 5 in 3-on. These are the sums that I give you for practice, and these will be solved in the next video. In the next video I'll give you an end to this chapter, and after that I'll start the new chapter, that is, I have said you already, human eye and the colorful world. I hope you understand. If you have any doubts, and if you have any queries, or if you have any questions that you didn't understand from this chapter, you can definitely keep in the comment section, so that I'll solve and I'll show the solution in the next video. And this is for sure. I hope you understand, and don't forget to subscribe our channel. Thank you. And please do these sums, these are very important.